Hello. I want to talk about why we have this formula with the absolute value and not this formula without the absolute value. So basically, I want to do a quick review of absolute value, then I'll go into exploring this formula. So the concept of absolute value is simple. All absolute value is distance from zero. And we've talked about this in class, that distances are always positive. So that's why absolute value is always positive. So that's the concept. The algebra is, how do you make a negative number positive? Well, you multiply by -1. So that leads to this definition. The absolute value of a number is equal to a, if it's already positive. You don't do anything. And minus a, if it's negative. And the reason for that is if you have something negative, you multiply it by -1 to make it positive. So the absolute value of -3, we'd use that case as equal to -3, which is 3. Okay, so that gives us that. Now I want to go back to this question. So first, I want to show why this formula is better than this formula. Now that doesn't prove why it's true, but it just proves why people use this one instead of this one. And so here's my example. We have a nice simple geometrical problem. Here's the graph of y equal 1 over x. And we want to find the area between -3 and -2. Okay, so this formula is no good. And here's why. If -3 to -2, 1 over dx, if all we have is the natural log without the absolute value, we run into a problem. We get this is equal to the natural log of -2 minus the natural log of -3, and that makes no sense. You can't take a log of a negative number. Well, why? Let's say that we had the log of -3 is equaling L. That would mean that e to the L is equal to -3. But, as you know, e to the L is always positive. So that's impossible. So if we wanted to just answer this basic question, what's the area, and use integration, this formula does not allow it. So that's why it's no good. So let me illustrate the formula on that same problem. -3 to -2, 1 over x dx is equal to the natural log absolute x -2 minus 3. So quick, here's the geometry of the problem. Going from -3 to -2. Well, that's going to be the natural log of the absolute -2 minus absolute -3. Use the rules of absolute value, log 2 minus log 3. And if you take out your calculator, that's going to be about equal to 0.405. So the area would be positive 0.405. So this is a good formula. Okay, but why? Okay, we'll have to go back to absolute value to show that. So I'm going to show why that's true. So let me just write that so you have it. Well, remember, how do you find an integral formula? You take a derivative. So I need to take that derivative. Well, you can't take a derivative through an absolute value. You really can't do a lot of things through an absolute value. Because an absolute value, if we go back to the definition of an absolute value is two cases. So we have to consider each of these cases. So this derivative is going to be equal to the, well, first of all, let's see here that remember, absolute x is equal to x when x is greater than 0 minus x is less than 0. So This derivative is going to be equal to the derivative of the natural log of x without absolute value when x is positive, and it's going to be the derivative of the natural log of minus x when x is already negative. So we'll do each of these. So case 1, case 2. So in the first one, you know that one. The derivative of the natural log of x is 1 over x. That gives us this formula. Sorry. It doesn't quite give us that formula. That was a mistake. The derivative of minus x, so in this case we get 1 over x. That's what I meant to say. That's going to be the derivative of the log of something more complicated than an x is 1 over what you're taking the log of times the derivative of the log. So this is going to be 1 over minus x, the derivative of minus x. That's going to be equal to 1 over minus x times minus 1, which is 1 over x. Again, so here we get 1 over x as well. So what we get, derivative of log absolute x is 1 over x in both cases. So the result, the bottom line, d dx, natural log absolute x is 1 over x. Therefore, integral of 1 over x dx is equal to the absolute, which is the better formula. Everybody's happy. Thanks for your time.